Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 2 from the June 2024, the R paper of the International A-Level Pure Mathematics P1 Edexcel exam. And this is the R paper. I'm not 100% sure what R actually stands for. I know that it's something to do with either a replacement paper or regional paper. Normally when there's a leak or something, they have a paper ready for a reserve. It could be reserve paper. I don't know. If somebody knows exactly what it means, they can leave a comment. But anyway, the questions are quite useful on these R papers as well. So that's why I go through them. So first of all, we have this inequality. It's a linear inequality because it's made up of like linear terms. And we want to solve it. So we will solve inequalities in much the same way as we solve equations. Okay, so you see an inequality, you know how to solve equations. There's not much difference between them in terms of the process we go through. Okay, it's just the inequality sign doesn't become an equal sign all of a sudden. It stays an inequality sign all the way through. So what we got to do is we got to first expand the brackets. And don't forget, which is a very common thing, to expand the bracket and multiply the number outside with all the terms inside. So 5 times x, which is 5x. 5 times 3, which is 15, is greater than 4 times 2x, which is 8x, and 4 times negative 5, which is negative 20. So here we have this inequality. Now the x's have been released from the prison of the brackets that they were in by expanding the brackets. So now they're free to move around, and we can now start to try to solve this equation. Now, there are 2 ways to proceed, and I'm going to show you both of these 2 ways. One of the ways is the way that I would normally go about it, but the other way brings out some very important points that will help us understand inequalities in a better way. All right, so the way that I would normally do this, in my own personal way of answering these questions, is I would say, okay, I want to keep the x's on the side where there are more x's. So I see that on this side I have 5 x's, on this side I have 8 x's, there's more on this side, so this side is going to be for the x's, and this side is going to be for the numbers. Okay, so on this side I have 8x, now the 5x is in the wrong side, so I have to get rid of it from here. How do you get rid of it from here? Well, you subtract 5x from both sides. So I subtract 5x from this side, so I subtract 5x from this side. And on this side, I have 15 already. The numbers, that's in the right place. I want the numbers to be on this side. Now this negative 20 is in the wrong place. How do I get rid of negative 20? Well, I add 20 to both sides. So this becomes 15 plus 20. Notice how I don't say move it to the other side. I don't like that terminology because people just start doing all sorts of stupid things later on in their maths lives when they think things can just sprout wings and fly around. No, we wanted to get rid of the 15 from this side, so we subtracted 15 from both sides. Sorry, we wanted to get rid of the 5x from this side, so we subtracted 5x from both sides. We wanted to get rid of the negative 20 from this side, so we added 20 to both sides. That's why it looks like this now. So 15 plus 20 is 35, and that's greater than 3x. Now we're going to divide by 3, so 35 over 3 is greater than x. Now that means if 35 over 3 is greater than x, that means x must be less than 35 over 3. You can leave your answer like that. You can also write it as x is less than 3 goes into 3 1 time, 3 goes into 5 2 time, 1 time again, remainder 2. So 11 and 2/3. You can write it as x is less than 11 2/3. You can leave it like this. But the important thing here, in the end, you should write your x on the left side. It's better. Okay. If you leave it like this, it's still probably going to be acceptable, but it's best to leave it on the left side. So if it says 35 over 3 is greater than x, that means x must be less than 35 over 3 just by using a bit of logic. So that's the answer. And that's how I would normally answer the question. However, there is an alternative method that people would use, and there's nothing wrong with using either of these 2 methods. So I'm going to show you how it works. And I'm going to show you an important point that this brings out, which many people mess up with. Okay, so this is one reason why this method, sometimes people mess up with it for this particular reason, as we'll see. So some people say, I don't care whether the x term ends up as negative. I'm going to keep the x's on the left side no matter what. So they'll say, okay, this is the left side. This is for the x's. I don't want the 15 here, but I want this 8x in the wrong place. Let's subtract 8x from both sides. So you end up with this side saying 5x minus 8x is greater than, and here I have negative 20, that's in the right place, but this 15 is in the wrong place, so I'm going to take away 15 from both sides. This is negative 15. So negative 20 minus 15 and 5x minus 8x, that gives you negative 3x is greater than negative 35. Now, the next step is what's really important. I want to get rid of this negative 3. So I have to divide both sides by negative 3. And this is where I'm going to stop. And I'm going to just go through something really important for you to understand. So I'm going to write down the number 8 and the number 4. Okay, I'm going to highlight them. Okay, the number 8 and number 4. And if we think about it, 8 and 4, what sign goes between them? Well, greater than. Now I'm going to take these two terms and I'm going to add 2 to both of them. So if I add 2 to 8, I'm going to get 10. If I add 2 to 4, I'm going to get 6. Is 10, what inequality sign right between them? Well, greater than again. That didn't change. So I'm always going to refer back to these two, and just make a little line here. I'm always referring back to those two in this little experiment, you could say. Then I'm going to take away 2 from both of these, the ones that I've highlighted. So 8 take away 2 is 6. 4 take away 2 is 2. Okay, and we can say that again, greater than sign applies. Then I'm going to multiply both of these by positive 2. So 8 times 2 is 16. 4 times 2 is 8. Again, 16 is greater than 8. The inequality sign is still, unaffected. If I divide both sides by 2, 8 divided by 2 is 4. 4 divided by 2 is 2. I'm left with 4 is greater than 2. Again, inequality sign is unaffected. Okay. However, if I multiply by negative 2, 8 divided by negative 2 is negative 4. And 4 divided by negative 2 is negative 2. Now, if you think about the number line, negative 4 is over here and negative 2 is over here. Negative 4 is less than negative 2. So the inequality sign was flipped when I multiplied by a negative number. And if I divide by negative 2, you'll have, oops, I did the wrong thing there. Okay, this is for dividing. Just imagine I did that for the dividing part. Okay, so this was for the dividing. What am I doing? Sorry, I think you still got the idea. I messed up a bit there. So this was for dividing by negative 2. As you can see, the inequality sign, it changed its direction. Okay, and you'll see if I multiply by negative 2, the same thing will happen. I'll get negative 16 here, and I'll get negative 8 here, and negative 16 is less than negative 8. As you can see, negative 8 will be here. Negative 16 will be further to the left. So negative 16 is less than negative 8. So we end up seeing that in these two cases, in the cases where I multiplied and divided by a negative number, the inequality sign changed its direction. Which means for our question here, why did I go through this? Just to prove something to you that we should know, that when you divide the inequality by a negative number, then the sign must change direction. So this negative 3x divided by negative 3, okay, and negative 35 divided by negative 3, that's going to become positive 35 over 3. But the inequality sign had to change direction as well because we divided by negative 3. So you see we end up with the same answer. X is less than 11 and 2/3. Okay, so there is our answer for this part A. All right, so some very important points come out of this, especially this section here. I normally would do it like this, and just at the end write X is less than, if 35 over 3 is greater than X, X is less than 35 over 3. But there's nothing wrong with doing it like this, and this important point comes out from this, and you need to remember this for certain other questions that might come up. Very important point. You divide or multiply an inequality by a negative number, the direction of the inequality sign has to reverse. Okay, so that's part A. Okay, now for B part 1. So here we're told to write x squared minus 6x plus 1 in the form x plus a squared plus b, where a and b are constants, and hence solve the inequality x squared minus 6x plus 1 is greater than or equal to 0. So the first step is, part 1, for us to rewrite this in a form which is called completing the square. We've got to complete the square for this. So when you complete the square, the first thing you've got to make sure is that the coefficient of the x squared is a square number. In this case, we want to make sure that it's 1. It's 1x squared, that's fine. We can proceed to complete the square. So when you complete the square, you want to have a bracket that's squared like this. You're going to have x, and then whatever sign you have here will go inside there. In this case, it's going to be negative. And the number, the coefficient of x, you take a half of that coefficient, it gives you x minus 3. X minus 3 squared. Now, if you think about this, if I expand this, I'm going to get x squared. I'm going to get minus 6x. I'm going to get plus 9. Okay. Now, this is not x squared minus 6x plus 9. This is just x squared minus 6x, this part of it. I'm just concentrating on this part first. X squared and the x term. So what I have here is not quite the same as that. There's something that I have to do to make it the same. So as I said, if I expand this, I'm going to get x squared minus 6x plus 9. I want to be left with just x squared minus 6x. So what I have to do is I have to take away the 9. If I take away the 9, then this will become x squared minus 6x, because you have x squared minus 6x plus 9 minus 9. So I have to take away always the square of the number that I write inside this bracket. Okay, now these are the same. What's highlighted, the things that I've highlighted are the same as each other now. So now I've got plus 1 at the end. So I've got to put plus 1 at the end there. So this is going to give me x minus 3 squared minus 8. Okay, so there I have completed the square and written this in the form that they require. Right? So now they didn't tell us to write down what a and b are, but if they did, a would be negative 3 and b would be negative 8, according to this. Then it says hence, and here we have a very important word, hence. Solve the inequality. So now part 2, we need to solve the inequality x squared minus 6x plus 1 is greater than or equal to 0. So how do I solve this inequality? Okay, let's have a look. Okay, now, if the question did not say hence solve, then we would have gone through the following steps. We would have said, okay, first of all, we have to find the critical value. So I've got to find when x squared minus 6x plus 1 is equal to 0. If I want to find where a quadratic inequality is greater than or less than 0, I have to find when it first equals 0. Okay. Now, what I would have done after this would probably be use a quadratic formula if I couldn't factorize, which you can't do, and then find the values of x where this equals 0. But because it says hence, I'm going to use this form and solve the equation x minus 3 squared minus 8 equals 0 using completing the square, right? So what I'm going to do is I'll say this means x minus 3 squared is equal to 8, which means that x minus 3 is equal to plus or minus the square root of 8. So x is equal to 3 plus or minus the square root of 8. Now the square root of 8 can be rewritten as 4 times 2. Remember, 8 is 4 times 2. The square root of 8 is the same as the square root of 4 times the square root of 2, which is 2 root 2. So this is 3 plus or minus 2 root 2. So those are where this is equal to 0. This is called the critical values. These are the critical values. Trying to find the critical values. Now, the critical values are the place where the graph of this x squared minus 6x plus 1 will equal 0. So if I draw a little sketch of this graph, okay, we know that it's a smiley face. We know it grows through the x-axis at 2 places, 3 plus 2 root 2, which is a positive value, and 3 minus 2 root 2, which is also positive, because remember, root 2 is 1.4. 2 times 1.4 is less than 3, so it's going to be somewhere over here, and goes to the y-axis at 1. The y-intercept will be 1, x is 0, y is 1. So it's going to look something like this, if you were to draw it. Okay, this is how this graph would look. And these are the critical values, 3 plus 2 root 2, and this one here is 3 minus 2 root 2. Okay, so those are the critical values where it crosses, where it equals 0. So these are the places where it equals 0. These are the places where x squared minus 6x plus 1 equals 0. We want to find where it's greater than 0. Okay, so we found using completing the square where this is equal to 0. We want to find where this is greater than 0. Now it's greater than 0 when the output is going to be a positive output above the x-axis. So for example, if I put x values anywhere between these two into this, it's going to give me a negative output, which will be less than 0. If I put these two values in, it's going to make it equal to 0. If I want to find values that makes this greater than 0, I have to choose values of x which are on this side, and on that side of these points, the 0 points basically. So I need to solve the inequality. I'll say x has to be less than or equal to, because it's got equal sign, I put equal to 3 minus 2 root 2. And also from this side, x must be greater than or equal to 3 plus 2 root 2. So these are the solutions for this inequality. Okay, these are the solutions for this inequality. And then part C says hence. So using the answers that we found, find the values of x that satisfy both of these inequalities. Okay, both of these inequalities, the one that we did for part A and the one that we did for part B. Okay, so the answer to part A was x is less than or equal to 11 and 2/3, no, less than only. Okay, so the answer to this was x is less than 11 and 2/3. We don't have to resolve it again. Okay, this is exactly the same question. We can make sure. Yes, it is. And for this second inequality, these are the solutions. X is less than or equal to 3 minus 2 root 2, and x is greater than or equal to 3 plus 2 root 2. So if we make some sort of a number line and try to draw these values on somehow. Okay, so let me do something like this. Choose a different color. Okay, so we have x is less than 11 and 2/3. So that would be like a line that goes like this. Okay, just say this is 11 and 2/3. Okay, and that would be less than, it would be an open circle. All right, and then we have x is less than or equal to 3 minus 2 root 2, and x is greater than or equal to 3 plus 2 root 2. So let's say this is 3 minus 2 root 2, which is less than 3 plus root 2 root 2. Let's say that's 3 plus 2 root 2. Okay, so for this one, you're going to have a arrow going this way. For this one, you're going to have an arrow going this way. That will continue on forever that way. That will continue on forever that way. And this will be a closed circle. And a closed circle meaning those 2 points are also included. So we want to find where these will overlap. So on this side, they're going to overlap, basically going on forever this way. Okay, they're going to overlap going on forever this way. So from this point onwards, they will overlap. But from these, they'll start overlapping here and end over here. So the solutions that satisfy both of these inequalities, both of these two inequalities, are when x is less than or equal to, because this is also included, 3 minus 2 root 2, and between these two values. So that's one that goes on forever. Here it starts and stops. So it starts at 3 plus 2 root 2, and x is greater than that or equal to it. And here you can't include the 11 and 2/3 because it's not included from this one. It's included from here but not from there. So we put less than 11 and 2/3. And here we have the answer which satisfies both of those two inequalities that we solved from part A and part B. Okay, so that concludes this question. Other questions from this paper can be found in the playlist that will appear on the top right of the screen at the end of this video. Other questions from the topic of inequalities and inequalities and regions and so on can be found in the playlist that will appear in the bottom right. I'll also put solving quadratic inequalities here, which is going to be kind of part of it anyway. And you can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.